Hello. I realize this is the last talk of the day. I realize everybody's hungry, and I realize that large parts of my talk have already appeared in other people's talks. So I will just use references and components. I will tell you the offset and the location. And Designspaces is a little bit on the things that Frederik and Adam were talking about. I feel it's not a finished thing. There's a bit of code, there's some GitHub links. It might be a little bit technical, but it's just a thing that I thought I have to discuss and show. So here we go. Behold, as I guide our conversation to my narrow area of expertise. There's a bigger laugh than that. No, that's sorry. A design space started in a long time ago as a way to describe, as Frederik said, the relationship between masters, between sources. So a font would be here, a font would be there, and you say, well, now I want to interpolate between them. How do you call it interpolation? What are those coordinates? How do you call the bits in between? All those bits of data are something else than the font. They don't belong in a font. A font should know about glyphs and font info and kerning, but not about stuff that is outside it. So all of the things that relate to a family, to things that have to interpolate but are not fonts, is stuff that will go into a design space. All of this, of course, is in flux, and things will change, so for the time being, and all of the data will change, and what variable fonts mean will change, and what interpolations mean will change. So specifically, the Designspace file as it exists right now, it was sort of like a superpolator document, but then it made it a little bit simpler. Adobe helped making mutator math public and open source, and I needed the file format for that. FontTools reads it, the FDK reads it and does stuff with it, and there's a little extension for RoboFont that does it, but all of these tools have a different idea what a design space is or what should be in there. And in order to, I felt like all of these cats were running in different directions, and I wanted to sort of get them together and see if I can actually define in one place and one bit of code and one format what a design space is. So, mutator math is a useful tool to calculate these kinds of things. It used to read and write Designspace files, but it wasn't really an editor. It would read them and then generate instances as fast as possible. That was its only purpose. Then Beta started using it for varlib, and it needed different things that were not really supportable in superpolator or a mutator math, and anyway, that's how it went. It's not supported everywhere. Not everything is supported everywhere, but at least it's a format that can contain these things. It's just to store it. So the differences between mutator math and variation model. This is what you came for, and it is the most exciting part of the presentation. Mutator math is something that I started writing in 2004, based on my recollection of working with the mutator tool in 1993, maybe, when I worked on the gem font for GX. I had not seen the specification. I think at that time it might not have been available. I just thought, how should this work? And it became sort of a definition of a design space. It had extrapolation in all directions. Masters would do really complicated things, and it became a useful tool in type design. Variation model is something that Bedat wrote much more recently, and he actually knows what he's doing. He's a really good engineer, and he's a really good mathematician. So it was, when Bedat started talking to me about this, it felt like I was having my mathematics checked, my homework checked. And I was about as nervous as I am right now. So that was, weren't any mistakes as such, but it was like done differently, and it was really nice to see how it actually was done. So now these things exist right next to each other. Variation model is really useful if you want to make variable fonts. Mutator math is really useful in Superpolator, and there's a whole bunch of people who use mutator math to make instances and UFOs and normal fonts, non-variable fonts that also have to interpolate and do their own things. So, but there are some differences. All right, using Drawbot, the awesome Drawbot. On the left, there's a design space, and on the right there's a design space, and there are no axes. It's void of everything. This is what the universe looked like before the Big Bang. There's a white circle, not much else. These maps are generated by a method that I've grown quite fond of to check interpolations and how masters work. Rather than putting a glyph in one of these mutators, I put a little group of color values in there. So a color is just now a value for red, for green, and for blue, and if you like, for an alpha as well. So rather than putting sequences of numbers that represent glyphs, I put in little sequences of numbers that represent colors. And then if you put a color in one place, you put another color in another place, and you use a mutator or a variation model, you can get intermediate colors, and you can see very quickly what happens. And oh boy, does it happen. So the thing in the middle, that's the neutral, that's the central place that I start with, the glyph that you start with. In this case, the color that I start with, and I call it gray. I add one master on that side, and the master is yellow. So we can see from gray, you see a couple of steps, it interpolates to yellow. We see the same thing in variation model, but we also see lots of gray. And this is because variation model as it is right now, and maybe it will change, but it does not know anything beyond the space where the masters have gone into. So for variation model, the world exists between gray and yellow. With mutator math, I wrote more as a design tool rather than a production tool. I want to see what's beyond there. I want to sort of take my little design space navigation doohickey and see, well, what is beyond this bolt that I drew, or what is beyond this thin that I drew? What are these extrapolations like? Because sometimes there's useful stuff there. So what happens here? If I go to the left of my master, the values that make up gray, the values that make up the yellow, then sort of interpolate and then extrapolate, and they become the opposite, and it becomes blue, because blue is the opposite of yellow. So the blue represents, in this field, all of this, basically an extrapolation of the yellow. You with me so far? Yeah, you want to get some coffee? Now, I add another master, a pink one, and the things are looking the same again. So left of my gray, I add a pink, and I will see a nice interpolation from gray to pink, and extrapolate stuff beyond that, so the universe is complete again. And even within a variation model, it kind of looks similar again. So the weird blue stuff is gone, and now there's interesting pink stuff. So within, if I just look at this box, the results are the same. If you look outside this box, the results are different, but at least now it's reliable again. I add another master. Is that correct? Yes, it's in between the magenta and the gray. I add a blue. Still on one axis, it does its nice little thing. All of the results are limited, but now this kind of tends toward red, because this master influence sort of extends beyond that. This is also why I had a difficult task actually figuring this stuff out, because once you're sort of in this, if you're outside of the masters that you've put in, you kind of have to sort of look into the design space and figure out what the masters are doing, and guess. And I was really guessing on how the variable fonts or the GX engineers had done this. But again, the models are the same. The results are reliable. Okay, good. oh geez, what happens here? I add another master, but I put this on a new coordinate. I say, well, we're not on this boring horizontal axis, we're just going to put it on another axis. So it lines up with the gray master, but now all of a sudden we have a two-dimensional space rather than a one-dimensional space. And mutator math lights up because there's extrapolations everywhere. And if you were to look at the letters, now, if these were glyphs, all of the crazy super outlier extrapolations would be weird, and they would not be useful. I mean, except for maybe making little animations and put them on Instagram or something. But typographically, they would have very little value. But very close to the masters, they are useful. So it's not just, do we want to extrapolate a little or not? We just, you make it possible, and then you can do crazy things, or you can also do useful things. Again, just between the masters, mutator, variation are good friends. And then this was a test thing. Another master, but sort of almost not lining up with the yellow one. And then this is okay in variation model, but you can tell in mutator math, because they're so close together, the extrapolations go up in the sky. And you have a beautiful abstract picture on the wall, but typographically it's not going to make that much sense anymore. So there are differences. Oh, and I've lost my screen. Okay, all right, that was it. So these differences exist. I don't think one is better than the other. I hope that maybe we can sort of work towards a more predictable model and more of the incorporate all of the good stuff that Beta has invented and put it in there. The thing I realized when Beta explained how it actually works is that deep down, the variable font format doesn't need any of this. And this was sort of a quantum mechanical discovery. It's like, wait, hang on. The reality as we understand doesn't actually necessarily have to work this way. So the fact that you have one master here and one master there, and if you're at this master, the effects of that master are gone, and if you're at that master, the effects of this master are gone. It doesn't have to happen that way. You can express that. You can say, I want these masters to behave in this predictable way, and create a reality that is comfortable for type designers. But the format itself can make these things work in any way, or at least now in a much bigger number of possibilities. So while we're building this in, and while we're building the tools, and while we're putting this in web browsers, while we're learning to think about how these models work, be cautious about easy solutions. Be cautious about tools that say, well, just put them in here, put them in there, and it'll be okay. Because we would be limiting ourselves from a lot of cool possibilities that would be useful. And we just wouldn't see them because the tools wouldn't allow it to go there. So there's that. Making Designspace files, a little bit of XML and a little bit of Python. So the Designspace document contains, at the moment, an element for axes. So that contains all of the stuff you want to have store about your axes, names, dimensions. An element for sources that contain links to your UFOs or your TTFs and more names, more Designspace locations. Instances are the things that you want to generate. In the case of superpolator and mutator math, you can actually generate UFOs. In the case of if you use a Designspace file in font make, those instances just become little coordinates and they become menus where you dial up an instance, but it doesn't actually make it, it just shows it. And at the moment, the fourth is an element that contains rules, sort of as a sketch on how conditional stuff could work. If the width is more than 500, then replace this glyph with that glyph. There's some problems with that as well, which we'll get to. So, XML, that's actually quite readable. Do you notice typeface? operator by Andy Clymer, which I think is awesome. All right, Designspace, access element, sources element, instance element, rules, yada, yada, yada. So what do we contain, what do we store in an axis? What do you want to store of an axis? The minimum value, the maximum value, the default value. So these are completely arbitrary, abstract measuring things. The minimum value is a number, the maximum value is a number. It could be 0 and 1, it could be -1, +1, -1,000, +1,000, whatever. The default is your favorite spot between the minimum and the maximum. So if you go between 0 and 1,000, you could say my default is 0, or my default is 500, or you could say the minimum is -1, the maximum is +1. If you go into a normalized space, the default could be 0. But it's a separate thing, you can store it. Axis name, something nice and readable, is basically a holdover of mutator math and superpolator. So this is, it has to be a string, and it can be longer than 4 letters, something like weight, width, optical underscore size, I don't know. I suppose you could even put emoji Unicodes in there, I don't know, it'll work. The axis tag is something that is defined, is a new thing that's defined in the OpenType specification. So that would be WGHT for weight or WDTH for width, and I always misspell those if I have to type them, OPSZ for optical size. Those things are registered, unless you write them in capitals, and then you can do whatever you want. There's a thing for a bunch of label names. If you want to have the name of the dimension, the name of an axis in an interface, and say, well, if we're showing this in French, this is what it's called. If we're showing this in German, this is what it's called. And a mysterious thing called map, which I'll get to. So, axis, XML, name, tag, minimum value, maximum value, default value, easy peasy. Label name, it already appeared on screen today, which is great because it's rather obscure. Has an XML language thing, so this is, I think, Farsi Iranian. This was an example by Bedat, and I think that word says wait, but I'm not sure. Anybody? Bedat? No. The map is also something, a type of information that belongs to the axis, and it maps input values to output values. This is something that could go towards this. Sort of mapping inputs to outputs. That's part of OpenType 1.8. Basically, there's a map element that says input value is this, output value is that, and the little graph here. So if you put the slider or knob or whatever value you want to have on 0, you want 50 to come out. So 0 maps to 50. It's pretty straightforward. So you can have bunches of them and emulate curves, or you just have a couple of them. In mutator math, this is supported. So in mutator math, you can actually put these values in, and if you call the instances according to these values, you will get the remapped ones out of it. If you want to experiment with it, the object in mutator math is called Bender. It's not at the moment entirely supported in FontMake, but maybe that will change. I don't know. The source element. There was a reason why I was not calling it master. I think the reason was because I was already using the word master somewhere. But a source describes all of the things you need to know about where your glyph stuff is coming from. So it would be a path to a file. This is my UFO at this folder. There's an element for family name and style name, which is part of the UFO. But in some workflows, it is useful to not always open up those files to get to those names. So if you need the family name and the style name of the source, it's already in the design space, so it's quicker to get to. And there's a location element that says where this master is going to be in the design space, and there are some flags about what to put in. So you can say, well, put all the glyphs in, don't put the kerning in, do put the font info in, those kinds of information. The instance element has a similar path, but it describes a fantasy. It describes the thing that you want. So the path in the instance element is sort of a wishful thinking. I wish there would be a UFO here, and I wish the family name would be this, and the style name would be that. And the style map names are in there as well, so if you want to make things for Windows. The PostScript name is in there because the FTK needed something, and there's also the location and flags. And a thing with glyphs in which you can define different masters in a particular instance. So you can say this instance, the lowercase a actually gets that master, and it takes that design space, or this particular location, which is not needed by anybody but Superpolator. And I think it's kind of a clunky way to solve some problems, and it's on the way out, but it's part of the format, so it's described somewhere. Location element. What is a location in a design space? It's a point in a design space, so it's a value along an axis. So you say, well, dimension, name, width is all along the width axis. My x value is going to be 100. What do you mean x value? Well, just value, okay. My value is going to be 100, and along the weight axis, my value is going to be 120. So that's some point in the design space used by sources and instances. But we also want to do crazy things. So anisotropic locations, the horizontals have different interpolation than the verticals. So there is a y value. So if you want to interpolate the weight axis horizontally to 120, but you want to have the verticals interpolate at a factor 200, then you can do this, and this is how you write it. So that's why they're called x value and y value. A thing of the rules element, which is both fantastically interesting and fantastically scary in terms of engineering. And I quickly discovered that this is way above my pay grade. But I put this in Superpolator anyway, where you can say, well, if the width is more than this value, substitute this glyph with that glyph. And I've already quickly put it in Superpolator. I had not really thought it out properly all the way, and quickly discovered that there were some complications if you want to make things a little bit more complicated. So what if those glyphs are used in components, for instance, or anyway. So Superpolator has something called rules. Who uses Superpolator rules? Oh, geez. Make no plans for the future. These things are going to change. Mutator math uses rules, but it has a little bit more developed. Again, with some valuable help from Andy Clymer, we developed some strategies that are a little bit more robust on how to deal with rules and substitutions and kerning, for instance, which is another hairy problem. The thing is that Superpolator now shows less than what Mutator does. So Mutator is a little bit ahead, and Superpolator does a nice graphic interface, but let's say that you have a glyph, and the glyph is substituted by another glyph because the rule is active, but then this glyph is used in a component, and this component is used in a component, and then you're looking at a preview that doesn't have any of these glyphs, and you're pulling the slider, and you want these things to change. Actually calculating which glyphs are affected by it it's already a lot more time than I have at the moment. So Superpolator does not really show it, but Mutator math does the right thing. So, and maybe Fontools will also. But so these things are very much still developing. If you want to have a look at it and think about these things, please, by all means, let's have a conversation. If you are planning big, complicated production things for your fonts, maybe not. And the FTK, Reed Roberts, is looking at how to express these things into feature text, where basically they're features, right? Substitute this glyph with that glyph, substitute this group with that group, ignore this group but then do that group, or position all of these, or even call other lookups. Those kinds of things should just be in the feature text. It has no place in the design space. But maybe for simpler substitutions, it could actually work. This is what it looks like. rules elements to collect everything. Single rule has a bunch of conditions. So if our location is between the maximum of 700 and a minimum of 100, so suppose we're at 500, that condition is true on the weight axis. Suppose for the width axis we are between 200 and 0, that condition is true as well. Then substitute a glyph named $, with glyph named $.alt, which looks great. And Mutator actually execute this rather well, but so not in a nice preview, and also not with groups and all of the fancy stuff that you would expect from feature text and gpos and gsub. So I wish I could have done this better. Let's put it that way, or at least know not to do it at all. Export-import. Superpolator has an export-import function for Designspaces. There was one release of Superpolator, I think 2 or 3 releases ago, that would actually have Designspace as one of the file formats it would natively support. But we quickly discovered that this was not a good idea either, because Designspace files don't store things about, for instance, color preferences or which text is in the preview or some other things. So some information was getting lost. So that was the reason to switch back to export imports, but this works really well. There's a small extension for RoboFont, as Frederik already showed. It's called Designspace Document Editor. It installs support for the Designspace file format. So if you have a Designspace file and you have this extension installed, you just drag it on RoboFont, you get this window, and you can edit your axes. You can say, well, the various names. It recognizes that if you have a WTH axis, it's a registered axis, but it will also happily take any of your non-standard axes. This editor, because of interface reasons, takes 5 dimensions, which should be enough. If you want to do, say, the full 1000 or the full 64,000 axes, you don't actually have to edit those all by hand. You can use the Python and then generate a Designspace file and execute it. So this is for normal quick edits. The masters are in there. There's a path. There's a couple of names, and then these are the places where this thing is going to live in the Designspace. So instances are in there, and there's a little bit of validation. It's a small and compact tool. It's not going to do any previews. That's going to be something that might live in the extension store. So scripting Designspaces. We have this XML file, and a lot of people have great enjoyment editing this by hand. Or using Xcode. You don't have to, so you can actually have a Designspace object that will read it, and it will represent the axes and sources and instances and rules as useful small little Python objects, and you can manipulate them and write the thing back again. This is sort of what it looks like. You've seen it all already. So an access descriptor. This is the thing, though. This type of data has classes of objects, and each class of objects has a lot of attributes, so I just solved it this way rather than making it a huge dictionary, for instance. So an access descriptor is an object that describes an axis. It doesn't actually do any interpolating or any math. It just stores the minimum, the maximum, the default, and you put the values in, and then you add the access descriptor object to your document, and then you're good. Source descriptor is sort of a similar thing. It has a path pointing to a file on disk. It has a name that is optional if you want to refer to this source in some other context. It's useful to have a unique name for it. And there's a bunch of interesting flags, copy lib, copy info, copy features, and I think there's one more that's all in there. So if you look at a font, most of the data is interpolatable. A glyph, a current pair, the units per M, the descender, the blue zones, all of these things are numbers and they interpolate nicely. But some of the numbers do not interpolate because they can't. Panos values or the old PostScript font ID number. There's no point in interpolating those. So some of the numerical values in font info don't interpolate, but it might be nice to get them from somewhere. So the copy info says, okay, this particular master, use it as a source, copy all of the things that are not calculatable, get them from there, so that you can have one source in your data. It says, well, if I need the Panos value, then it will come from there. Same thing for the features. This is the feature text. It cannot interpolate because it's just text. It would be nice if you could interpret the features and then interpolate those things, but it doesn't work that way. So you just say, one master, this is the source of my features, copy it from there. And the copy the library is also where all of the non-calculating stuff from the font lib comes from. The FDK, Reed Roberts, started using the copy info flag as the designated central, neutral origin of your design space. I discovered this after he started doing it. I would have thought of maybe a little bit more explicit way of writing this. So in Superpolator 1, the idea of the origin was very clearly defined. You would say, well, this is my neutral font. This is where it goes. And the font was called the neutral. And then you would add your masters that would be off-axis and on-axis, and you would build your space that way. In Superpolator 2, I thought, completely not anticipating variable fonts, and let's make things easier. I thought, well, it would be nice if the designation of that neutral, saying, well, which font is going to be the central part, if that was just removed, if that whole decision was just taken away from the user, wouldn't it be nice if the program would just figure this out themselves, for itself? So if you have 4 glyphs, you could say, well, this is axis, this is axis, this is the value, so I'll just take the bottom left one as a neutral. Find an algorithm that finds these, finds the best origin, and millions of glyphs served, so that seems to work. The nice thing then in Superpolator 2, if you're generating UFOs, is that suppose you have 3 masters on one axis, and there's master 1, master 2, master 3. For one glyph, you don't really want to draw all 3 of them, you just leave out the middle one. So you have one extreme, another extreme, you don't have nothing in the middle. Superpolator will say, okay, so for this one we don't have a 3-master system, we have a 2-master system, this is the axis, so I'll make that one the neutral. And that will work. So you can have really different interpolation topologies for every glyph if you want to make UFOs. You can have one glyph with one set of outlines that doesn't appear in any of the other masters, and that glyph will then appear, that shape will appear in all of your instances, because that's the neutral for that glyph. So it had useful things, and then variable fonts comes along and starts repurposing some of this work for making variable fonts, and then now we kind of have to rely on copy info doing its job. It go well. Instance descriptor, you say, this is my family name, this is my style name. You say, please put the UFO I want on that place. You can give it a location, which is a dictionary in which the axis name is the key and the axis value is the value. They're quite easy to make. In Mutator, there is an object called location, which is basically just a dictionary, but it has a couple of methods of making it a little bit easier. But you can just put a dictionary in this one. I want this instance to have kerning. So, okay, please do. And please also calculate the info. These are separate because maybe you don't actually want to calculate the kerning. Kerning might be a big thing. Kerning might not be ready. It also means that you can calculate the glyphs without, you can calculate the kerning without the glyphs, if that's what you want to do. And then you add the instance object to your document, and you're good. Then you save, you have a Designspace file on your disk. There are different ways of using this now, so you can call a build function from mutator math UFO. Just please, here's my path, here's my design space, go make, and it will crunch and process and make all of the instances based on the masters that you have there. So, if you use Superblader to make a nice a family, and you preview it, and you do all the clicky things that are needed, once you have a design space, you only need to call a script that says, well, please execute, and all of the instances will represent the newest masters. So you don't actually have to use Superblader to generate the instances if you don't want to. I'm working on a newer output method, which is called a UFO processor, that reads this design space object. Again, you make a design space processor object, you tell it which design space you want to read, and then you say, please generate UFO, and it does more or less the same thing. Under the hood, it uses mutators to generate the glyphs. Take a photo of this. You just go to Letterer on GitHub, and then all of this stuff is there. Designspace document has the specification. A Designspace document editor is the RoboFont plugin. And now I will show a little bit of the fun stuff to do with these things. Responsive lettering. And this. So, Designspaces, having fun with. Coverage is a fun statistical approach to measure weight and width in design spaces. You can imagine what weekends are like at my household. No. I thought, well, you know, the OpenType font weight value and font width values are kind of artificial and synthetic. Is there a numerical approach? Is there a way of looking at surface area, averages, something to deal with this? And that became this little experiment. If you go to GitHub coverage, there's actually quite a long piece of text in which I attempt to explain this. But basically, it's this. You look at the black shape, you calculate the surface area using the font tools area pen, again by Bedot, which is a number of square font units. And then I divide that whole thing by the rectangle it's on, so the width times the units per m. And everybody will already say, well, that's not really an objective way of judging the gray, the color, the patterns, the text appearance, all of that stuff. Yes, I know that. But it's one way of sort of finding a way into getting numbers that are slightly objective. Okay. Let's look at A through Z, capital, lowercase. Let's ignore white space. Let's ignore numbers. Let's ignore punctuation because there's all sort of white around it. Let's only look at the patterns that are made by capitals and lowercase. As if we're looking at this artificial, really long line without space, but with text. Oh dear. How many capitals are we going to use in our text? Because if we just use A through Z and A through Z, each letter will appear once, but that does not represent how text appears, because text is language, and languages have different frequencies. What to do? Well, here's the formula. Surface area divided by m times width for a single glyph, so that will give you some sort of a number. Light letters will have a small number, heavy letters will have a big number, crazy letters will have a really big number. Impossible letters will have a negative number. So what to do with a font? With the help of Bianca Berning and some questions on Twitter, I got my greasy hands on a table of letter frequencies covering a whole bunch of languages. You say, well, now for English, this many capitals and this many lowercase. For French, for German, for I think 27 altogether. Did some number crunching on that, saved it in a format that I can use. Now, I can calculate the coverage of every single glyph and then multiply it by this letter frequency thing. So it means that you can kind of calculate the color for a specific language. And then you say, oh, well, but can we tell the difference that this number is French and this number is German? No, because it's like 2 or 3 digits down the number. That's where the differences happen. So, but I average all of those results for all of those languages and say, well, this is the weight. So none of this is really scientific. It's just sort of exploring statistics. But it will give me a number that I can actually explain what it is, and with all of its shortcomings, I can actually do something with it. I can compare existing fonts, I can compare instances, what I want to do with them, and I can map weight and width. So here's a wonderful graph in which I calculate the weight value for a font, and then the width value is sort of stored that way. And this is a bunch of fonts I have on my computer. So times starts at 0.543, and it ends up being 0.576. That's a certain weight and a certain width. You can tell that Myriad is lighter. You can tell that Verdana, or Cecilia is heavier, or certainly a lot wider. All of these graphs kind of show what you already know if you look at these letters, but it's nice to sort of see it confirmed. You can tell Cecilia, the medium Cecilia, and the light weight of Verdana are actually quite close together. Does that mean anything? Well, they look completely different, but at least in weight and width, numerically, they're kind of close together. You can also plot this. So this is the weight for, I think on the left it's lowercase, and on the right it is capitals. If I have a design space, like I said, will give me the instance for 0 and give me the instance for 0.1, 0.2, 0.3, just a couple of hundred, calculate this whole thing and calculate what the weight value for every instance is. And you can tell, first of all, they're not straight lines, which I think is awesome. So you're thinking you're dealing with linear interpolation, but the results are going woink. Some glyphs are going faster than other glyphs. Capital M, I think this is Adobe Sans, but sort of way up there. Capital I is up there, way at the bottom. And you see glyphs sort of doing this. They start out lighter than one and they become heavier than another. Again, you can observe all of this, but it's nice to see that these things can be plotted and visualized. Then I came to this thing. This is again using Adobe Sans, because it doesn't have any intermediate, so it's a single square, 4 masters, a terrific, crazy typeface, ones drawn by Jim Wasco. It's kind of it has negative connotations because we only see Adobe Sans show up if something went wrong. So the fonts didn't print, and then Adobe Sans shows up, and we learn to point Instagrams at it and make fun of it. But the fact that it works, that you can still read the document, and that some people think it is so convincing that they will actually put the billboard up, I think is quite good. So there's a bunch of boxes going from dark and narrow to light and narrow to really wide light and really wide dark. That's the average width and average weight that I calculate for one of these instances. So I calculate instances for all of them. Then, using those values of weight and width, I can actually plot curves along which the weight would be the same. So a curve at which that weight value that I calculate would be a half or 0.6 or 0.7 or whatever. And the same for the width. So that sort of becomes this thing. This is a fun Saturday. Along the green lines, the average width is the same. So of the whole typeface, the average width is kind of the same. And along the blue lines, the average weight is the same. And then every dot would sort of mean a place where you can jump from a lighter weight, but keep the width, or you can jump to a wider font, but keep the weight. So it was sort of like lots of small adjustments. And first of all, it's totally not orthogonal, so it's totally not lining up with any of the axes. The lighter stuff, this is really, really dense. You can tell that, there's my calculations are kind of falling apart near the edges, and it doesn't go all the way through, and yada yada yada. It's not finished. I'm not a mathematician, but it's kind of a hobby. So, but jumping between the dots is then kind of an interesting way to navigate a design space, because you can say, give me something a little bit lighter, but don't change the weight. Width. Give me something a little bit narrower, but don't change the weight. And if you get closer to the edges, maybe you should be warned. But So this hasn't gone anywhere yet, but I think there's something else to do with. Another fun use recently added to the responsive lettering project is a variable font and Designspace export of the responsive lettering. So if you've done any responsive lettering work using my little extension, you can now make a variable font with one letter. This is the piece one, and that's also on GitHub. Another fun thing is remapping design spaces or making complex design spaces. So there's code manipulating these design spaces. And if you think of editing a design space in terms of superpolator and putting masters in and clicking buttons and putting all of this stuff in the right place, then that's, you don't want to make it super complicated. But inspired by the stopwatch in Zycons, and I think this is David's work, I wanted to see if I can make this work too. So I made a little script. It starts with something that has I can probably make that work because it's right here. So there's one font that has the dial and the arrow, and there's a Python script that just makes a couple of hundred instances, rotating this thing, and then inserts those as masters, and then puts all of those masters on a single axis called gauge, and then you pull the gauge and you have a thing that actually rotates. Of course, it's not a pure rotation, it's a sequence of linear interpolations, but for all intents and purposes, these things are turning. And it does not really need to be a full circle. You can also make them rotate in another way. So halfway, full, 0. So that's kind of funny. And this is the responsive lettering one, where the weight, of course, is completely independent of width. So you can make it narrow, and you can change the weight without changing the width because it wanted to fit. If you haven't seen the typemedia responsive lettering things, we're infinitely proud. This is one by Magda, where it animates between the handwriting of her father and her mother, I think. Yes. And it shows that it's a single glyph, and it's not a typeface, but it is a piece of lettering. That one of the design challenges is not necessarily going to be making all of the weights right, but also choreography. How do you animate? How do you make these things jump? What is an elegant motion? How do you solve this curve? How do you solve that curve? How do they roll over each other? How do these? And I think that's totally fascinating. And there's a whole bunch of them. Go to typemedia, you'll find a link. So I think here's a cool one by Matto. It looks like it's rotating, but it's sort of getting narrower, and there's crazy pseudo 3D things going on. And there's PageBot by Tom. Of course, I'm forgetting to do the most important thing, which is to actually change the. Where's another one? Is this the hyphen? So they respond to the page. So the page actually gets narrower. That thing will also respond to it. And this is a whole different talk. But if you imagine that you make animated type, you make lettering, we're all looking at it on our screens. But all of our screens are different. The ratios are different. The orientations are different. The sizes are different. So why not have these vector graphics just calculate and become the right size for your phone and your orientation, and then these things can work for everybody. So another one, Neil. I think this is a pretty good one. Going between two different Arabic styles. This is by Pablo. And of course, there's always little crunchy bits that you think, oh well, that doesn't really nicely work together, but that's what that's one of the design challenges. So if you have done responsive lettering things, you can now make a font. If you haven't, you can also make a font. Let's see, is there? How do I get back to a little demo? If you've seen this already, this is superpolator. These are the different masters. And you can say, open this up. You can say, here's an anisotropic master, or an anisotropic instance where you basically get 2 sliders. So you can do, of course it's not going to work because I'm demoing it. You can do crazy inverted contrast. Or you can discover inverted contrast. Look what I found. And generate things. I had RoboFont. So beginning to figure out how to work with different masters in RoboFont. Obviously, it's not a file format that has different sources, different masters. It's not the way that multiple master lives in FontLab, or the way that Glyphs does it. So we're dealing with separate UFOs. So I was thinking maybe if we can just start with the interface. So I have those fonts open. So give me the next one. And this is just interfacing. So I have these little scripts, and now the window is the same size, the zoom is the same size, it just goes to the next glyph of the next font. And already this kind of pretends that they're all the same project, but they're not. But for all intents and purposes in editing, this is quite fine. Then I added this, that just shows the deltas of each point for all fonts that are open. Now, I have the Adobe Sans open, so that they're super extreme, so might not be so useful. Like the wind is coming from the left, and all of the nodes are sort of blowing that way. But this was maybe an hour work and a little bit of curiosity, and saying, well, what if I just visualize it this way? And I'm super happy that with RoboFont 2.0 coming up and Drawbot, it is possible to very quickly experiment and come up with ideas and say, well, how would I make these interfaces? It's not going to be the GX interface. It's not going to be the multiple master interface, because it can be. You can turn this into multiple master, but it would be sad because we can do an infinite number of other things and better things. And let's play around and see what we can do. So we can learn, experiment. Okay. The beautiful interpolating maps were made with Drawbot. Here's the code. And I think I've bored you all enough. So thank you very much for your patience. If you have any questions, catch me later afterwards, or some other time. Not right now. Thank you.